So I think the first one that I want to demonstrate here for you is going to be one that has a cube. Let's do a cube first, okay? Let's do number one. Let's do number one. And what you'll see when you do number one on your paper is I asked you to not only transfer what number you're doing, but to transfer to the best of your ability the three-dimensional version of it. So this should be on your paper because number one is a cube. So practice drawing a cube. All right, why isn't it showing up on the screen? I don't know. Let's try. There we go. Everyone can see my cube now?
Yeah.
Yes. And let's add the dimensions now of that cube. So for number one, each of the faces of the cube were 2 feet, right?
Yep.
So the length, the width, the height were all 2 feet. And that's the cool thing about a cube is that every single edge is congruent. And so this is really easy to unpack. If you needed help with connecting what the net version of a cube is, then you flipped back to workbook page 253, right? And you saw that when you unroll a cube, it looks something like this, right? And then you have one piece that goes up and one piece that goes down, and it really doesn't matter where those two end up, right? As long as you have how many squares that unroll and connect back together. How many squares, everybody? 6. And they're all exactly the same. So yesterday we talked about the next thing you would do when you're trying to calculate surface area is transfer some dimensions to your net. So take the dimensions from the three-dimensional figure and transfer them to the net. So what would the length of this segment be, everybody? 2 feet. What would the length of this segment be? 2. Okay, so knowing that much information, I can calculate the area of this square now, right? Because I have a length and I have a width. And in order to calculate the area of any square, what 2 dimensions do I need? Length and width, right? The cool thing about this shape in particular is every single one of these shapes are exactly what? The same. They're congruent. So if I know the area of one star, how would I figure out the total area of this shape? How many stars would that be? 6 of them. So you can label them with symbols. You can label them with letters. You can label them any way that you need to. Some people like to color them all the same shade to indicate congruency. What's congruency mean? Equivalent, equal, same size, same shape. So could we find the area of one star? We would need the formula length times width, right? And what is length times width in the case of one of these squares? 2 times 2. And what's 2 times 2? 4. So if we know the area of one star is 4, what would the area of 6 stars be? 24. Good job. Now we just need the units here. 24 feet, and we're going squared because this is a flat object. Now it's unrolled, it's flat. How do you feel about number 1? Good. So number 2 and number 5 are almost exactly the same, except what? Different dimensions. So for number 2, instead of having a 2 foot here and here and here, the only difference is for number 2, you're going to have 0.6 and 0.6 and 0.6. So these values over here would just change. You'd have the same net to 0.6. So what would 0.6 times 0.6 be? 0.36, right? So 36 hundredths meters squared would be the value of one of those sections, and then multiply it times 6 to find the total area of that entire shape. Good? What about for number 5? What do the dimensions change to for number 5? They change to 1.2. So same exact procedure. It's a cube. Unroll it. Find the area of 1 square. Apply it to the rest of them. Helen, would you mind closing that door for me? All right. Hey, let's move on. I'm going to do 1 prism, and then I'll do number 6. I know that one was tough. Ready? Here's one of the prisms. This one's number 3. So when you looked at this prism, it's sort of shaped like maybe a ream of paper, right? It has this, or maybe a book, something like that. I'll try to get this corner lined up. 3-dimensional things are tough to draw, aren't they? So you got to draw depth, maintain parallel lines throughout as best you can. So the labels on the diagram in your workbook call for this length is 6 feet. What other length would be 6 feet as well? If you know from here to here is 6 feet, what else do you know is 6 feet? The one that is directly where? Across from it. So this one, you could also label this 6 feet if it helps you understand the unrolled version a little better. You can over-label your work. Now, what would the width of this shape be? It said 5, which also means the top part is 5 feet. So look at the height of this shape now. What is the height of that shape? It said 2 feet. If you need help unrolling this shape, you're going to look on workbook 253, and you'll see that you have to unroll a rectangular prism to show the top, the bottom, the left, the right, the front, the back. So if it makes more sense for you to unroll it coming at you or coming apart left to right, you decide. So I'm going to draw on my net and check yours to see how we kind of relate. I'm drawing the top, then I'm drawing the thing on the right, then I'm drawing the bottom, then I'm drawing the thing on the left. And now I have to connect sort of that front and back flap. And you can connect them anywhere as long as they kind of connect in the same location. That should help you understand the dimensions a little better. Do you have a net similar to mine when you unrolled it? If it's a different position, that's fine. We just have to transfer some of the dimensions now so that we understand it fully. So what was this longest side called? How many feet was it? It was 6. So is it safe to say if this is 6, then this is 6, then this is 6, right? All of those lengths along this edge are 6. Agreed? Now, how about this side that is connected to the top of the box here? This one would be 5. And what other one would be 5? The one directly across from it. Anything else? On this rectangle?
Yeah. No.
No. This one?
Yeah.
Yes. So this is 5. This is 5. Good. And we know these are 5. These are 5. And then let's transfer the 2 lastly. 2 and 5 have to be connected to each other. So that would be right here. And that would be right here. Because when this gets folded back up, these two seal together, don't they? And so they both have to be the same size because they seal together. That's where they meet. This one's 2. This one's 2. So we made this suggestion in the other class that when you have a figure that has differently shaped surfaces, different rectangles, that you can label them like AA, BB, CC. You can label them stars and hearts or whatever you'd like to label them at. Or your last option was to kind of shade them. So if this is the green shape, here's the other green shape. Can you see that? So some people like the very visual version of, hey, there's my green rectangles. They're exactly the same. Here's my blue rectangles. They're exactly the same. Here's my yellow rectangles. They're exactly the same. Okay, so maybe if you want to treat it like that and say, hey, I have 2 yellow rectangles to figure out, 2 green rectangles to figure out, 2 blue rectangles to figure out, but all together, that represents the total area. You might enjoy that version too, okay? So the total area of this net would be, let's call it 2 greens plus 2 yellows plus 2 blues. Would you agree that that's one way to label it? You can label it with letters or colors. It's up to you. Stars, hearts. So how do we calculate if we know that this is how we get the total answer? Let's decompose it a little bit. How do I find the value of just one of the green rectangles? What's the formula for a rectangle? Area equals what? Length times width. Okay, zoom in to what is the length and what is the width of that green rectangle. What's the length and width, everybody? 5 times 6. Good job. So what would 5 times 6 be? 30. Good. So we know one of the greens is 30, right? How about one of the yellows? What are the dimensions of the yellow rectangle? 5 times 2. You got it. So 5 times 2. What is the dimensions? 10. Good. And lastly, the blue. What's the dimensions on the blue one? 2 times 6. 6 times 2. Good. And the result would be 12. Now, in order to calculate the total area, we're just kind of evaluate. We're going to plug in the values where they need to be. So 2 times 30 plus 2 times 10 plus 2 times 12, right? What did you get when you calculated that? I'm going to kind of evaluate off to the side here. 2 times 30 plus 2 times 10 plus 2 times 12. So that's going to be 60. That's going to be 20. That's going to be 24. What do we get as a grand total there? 104. Okay, give me my units of measure. 104 what? Feet squared. Well done. How are you feeling about the prism now? A little better?
Better.
What do you think, Izzy?
So, I didn't like what was this one because I didn't draw it out. Like, I drew some of them out, but like some I just like I wrote it. So like the size was 6 times 2, and then I got 12, and then I did that 2 times, and then I got the top 6 times 5 equals 30.
Okay.
And then I did the bottom and the front and the back, and then I added those up.
So Izzy was saying that she did not draw the net, but was still able to kind of decompose the shape, knowing I needed a top and a bottom, a left and a right, a front and a back. She knew that. And that's okay. As long as it doesn't say use a net, then you can do what you want. On the instructions last night, it said use a net. So
I did use a net.
Okay.
I used a net.
you used a net to help you. It did not say draw a net and then label it. And then this is just one, I guess, strategy people use to understand total surface area is they use the net and kind of map it out and take it piece by piece like a puzzle. So let's look at the trickiest one. You ready? What number was that?
6.
Number 6. Everyone at home okay? Is this helping? I had a couple more people said they were going to be here. I'm wondering where they're at. Yeah, they're sleeping. They're taking a nap. This one's number 6. Well, at least we're recording it. Then they can hop on later. So this one was tricky for a couple of reasons. First of all, there's triangles involved, right? Second of all, the triangle here is not an equilateral triangle. It has, this is 10, this is 10, but what's the base of this triangle? It's 12. So when you unfold it, the rectangle on the left and the right are going to have a width of 10, but the rectangle in the middle is going to have a width of what? 12. So the ones on the flaps are going to be the same, but the one in the middle is going to be different. So that's something to be careful about when you're unwrapping this, this net. So if you did it, paying attention to that 12, that middle rectangle is going to be a little bit wider. And the ones that come off to the side of it that fold down from the point are going to be a little bit more narrow because those have 10s as a width. Does that make sense? And then what would the length of this be right here? 20. Good job. That's hard to see. Now, what about those triangles? Where do they come into play? We connect them to where? We're going to connect them to the 12s. And it looks like I drew my picture a little bit. Just a little bit too high. Sorry about that. Can you see that there's a triangle up there, I promise. And his base is 12. And what is the height of each of these? 8.5, did it say? Oh, 8. Okay, just 8. So the height of this triangle is 8. And it's important to know the height because the formula for the area of a triangle requires base times height divided by 2. So we have that information. We just have to actually apply it. Hey, let's label it. So we have 2 rectangles that are exactly the same dimensions, right, Natalie? We have 1 rectangle that doesn't match anybody at all. And then what about the last triangles? We have 2 of those that are exactly the same size and shape. So you give me a little formula for the total area. The total area will be how many A's? 2 A's. How many B's? 1 B. And how many C's? 2 C's. That's going to be your total area formula. You kind of built it based on your labels, okay? All right, let's calculate the value of 1A. How do I calculate the area of this shape? It's a rectangle. Length times width. What's length times width in this case? 20 times 10. What's 20 times 10? 200. Good. What is the area of B? Let's look at this rectangle here. It's a 12 by what? It's a 12 by 20. So length times width this time is going to be 12 times 20. Do that quickly by saying, what's 2 times 12? What's 2 times 12? 24. Add a power of 10 on the back. 240. Good job. All right, lastly, the area of the triangle. What's the formula? I gave you a little cheat sheet yesterday. What's the formula for area of a triangle? It's base times height divided by 2. So base times height divided by 2. Let's plug it in and then we'll do the calculations. What's the base of this triangle? What's the length of the base? 12 times the height, 8 divided by 2. So feel free to cut these down if that would help you multiply quicker, or multiply these 2 guys and divide by 2. What's your final answer there? What's 12 times 8 divided by 2? 48? Yes.
You don't actually have to do the divide by 2 because you have to times it by 2.
No. So if you recognize, hey, I have 2 triangles, I really don't have to do the dividing by 2 part because I'm just going to be multiplying by 2 again when I plug it back into the formula. Yeah, you got it. All right, let's go plug it in. What would 2 of 200 be? And 1 of B and 2 of C be? Can you figure out that total calculation? What did you get here? We got 400 plus 240. That's 640 plus 96 more. What do you get all together? 36? Did you say 736? Okay, and then we have meters squared. It's a flat shape. Is your brain going womp, womp, womp?
Yeah, mine's dying.
It's okay. It's okay. Yesterday, we did number 1 on 257. I'm going to do number 2 and number 3 with you, and then you can do your homework, okay? So everyone open. You don't have to even open your workbook at all, unless you want to look at it. I'm going to draw number 2 and number 3 from 257. You're going to write it just in your work, in your notebook, okay?
Since we're taking loosely. Oh.
Do you have your notebook with you?
Mine's still at home. I wasn't able to find it last night. I have.
I don't have any loose leaf. Maybe grab them.
I have loose leaf in the binder. Okay.
257, number 2. I'm going to start drawing it, okay?
You have to move, if Victor moves a little bit, it's the top shelf in the left-hand side.
Is it you need loose leaf?
I got no tape, so she can.
Oh, boy.
Down to the office,
I'm having,
unless she knows that she has extra tape, I don't have any more.
what you need tape for right now?
I ripped his book. Okay.
Can we problem solve that after I'm done with my Zoom? Okay. Let's just use your notebook paper right now, okay? I'm transferring to the best of my ability, guys. This pyramid. And the height of this pyramid will represent the height of this particular triangle here, okay? What is the height of that pyramid labeled as in your workbook? If you have it open, it says 11 centimeters. Now the width of this length is 5 centimeters. And the width of this length is also 5 centimeters. So what do we know about the bottom shape? What kind of shape is it? If the length and the width are both 5, what do you know about it? What do you know about it, Shane? It's a, oh, what's a flat version of that called?
Triangular.
No.
Triangular circle.
Here, let me just draw the shape. And then Shane's gonna answer. What is the shape that you see on the bottom?
Triangular.
No. What shape is it? Thank you. It's a square. And we know it's a square. Hang on. We know it's a square. Why? Because what labels prove to me it is a square? How did we know it was a square? They're both 5 centimeters, which means every single line segment that surrounds that shape is length at 5 centimeters. Therefore, they're congruent. What's congruent mean? The same. Okay, now that we know that, can you take and kind of peel away those triangle tips, right? How many triangles will be on a shape that has 4 sides? 4. How many triangles will be on a shape, Colin, step, that has 5 sides? 5. How many triangles will be on a shape that has a base of 3 sides? 3, right? They will always be the same because the triangle's bases are connected to the base of the shape, okay? The base of that 3-dimensional shape. I tried to draw them equal, but I know I'm not the best when I'm Zoom drawing. I have a little like stylus pen here that acts as my mouse.
That's on the.
What you do? Or is it
That's
right
on
now?
page,
Yeah.
254.
See?
Cool.
I thought you were using a mouse.
Oh, no, that would be, I had to buy this because I was having such a tough time writing numbers and calculations using my mouse. My finger would be like dead at the end of the day.
Like a pad for it to like write on.
Yes, there's a special pad here. See?
Oh, fancy.
All the things, all the skills I didn't know I had until this year. Now that we have the net, now let's kind of think about what congruencies do I have? What duplicates do I have? So obviously the square in the middle is all by himself, right? We'll just label that A. That's shape A. We know the total area is going to be shape A plus those triangles. Are the triangles equal? And how do you know? Are the triangles equal?
Yeah.
I'm hearing some people say yes. Prove it to me. How do you know?
Because all of them have the 11 centimeters in height.
All of them have a height of 11 and a base of 5, right? All of them do. So if they all have a height of 11 and a base of 5, we know that they're exactly the same. So we can label them all B, right? So I know my total area is going to be 1A and how many B's? 4 B's. You got it. All right, let's find it. What is the formula for the area of the square? Length times width. And what is length times width in this case? 5 times 5, and that would be 25. What about the area of a shape that's called B? Hey, that's a triangle, right? So it's base times height divided by 2. What's the base? What's the height? Go ahead. 5 times 11 divided by 2. Okay, what is 5 times 11 divided by 2? It's not going to be an even number. It'll be a fractional number or a decimal number, right? 5 times 11 is 55. What's half of 55? Go ahead. 27.5. Okay. We need 1A, which is 25, and 4 times 27.5. Okay, can we calculate that? Someone type it into a calculator, that's good, or off to the side, figure out 4 times 27.5 and add 25 more to it. Here, I can just pop it up on my screen here. 27.5 times 4 is 110 plus 25 more. 135, guys? Oh, yeah. 135 centimeters, and it's squared because it's flat. So 4 times 27.5 is 110. 110 plus 25 more is 135. How are we feeling about this? A little bit more better. I won't tell Mrs. Senatori you said that. Questions, Alicia?
Did you have to divide the 55 by 2? Couldn't you just have multiplied it by 4?
No, because you don't have 4 shapes.
I mean 2, that's right.
You could have, but that's doing the same thing. I'm just decomposing the process for us so that we can all understand everything that's going on. If you're able to make that shortcut, Alicia, without making a mistake, go ahead. But in the end, you're doing the same process. I just like making a statement like this. This really helped me overall is what's my total area got to look like? What am I looking at? Break it up like a puzzle and handle it piece by piece by piece. Okay. Question, Ava?
So you did 25 plus 4?
When you do order of operations, what has to come first? Multiplication or addition? Multiplication. So you have to do these two guys first
Okay.
and then add it to the 25. Okay. It's kind of like our simplifying routine. Please excuse my dear Aunt Sally. Okay. PEMDAS coming back at you. Hey, one more. Let's do one more. Yeah. I'm going to do one more though.
Wasn't there like one acronym for like?
I'm doing number 3.
It says something about like.
Oh, it's another pyramid here. These are tough to draw. If you're drawing it on your paper, I would recommend you first draw the triangle you're looking at, and then draw the triangle that's kind of on the right-hand side of it. Okay. Draw a parallel line until you get to the spot where you got to come across for the base. And then usually the lines that are back tucked behind, you dot them so they look like they're in the distance. And I like to use a different color to show the height of the triangle that's coming off of it. That's going to be 15, it looks like in this case, 15. Do we have a perfect square on the bottom or no? Yes, and oh yay, we do, because that makes things easier. When we have a perfect square on the bottom again, that means all the triangles that connect to it are exactly what? Congruent. Use the word congruent. Congruent, yep. So again, hey, look I left enough space for my triangles this time. But we still have this sort of like flower open up of our pyramid. Let's pull some dimensions onto it. So this is going to be 12.2. This is going to be 12.2. The height's going to be 15. And that's on all of them. You don't have to label all of them. Just label enough for you to go, okay, I can do the area of that shape. I can do the area of that shape. All right. What do you want to call them? You want to color them this time or label them with letters? What do you want to do?
I just labeled them.
Okay, I'm going to color them this time. We've got yellow. It's going to be our square. And let's go with this pretty blue. And they don't look it very well on my drawing here, but they are congruent. So my total area, give me a statement that represents the total area of this figure. One of the yellow squares, right? Watch this. I'm going to even do. Do you like that?
That's very fancy.
That's very visually supportive, isn't it? Okay, talk to me. What is the area of just one of the squares? What's the area of one of the squares? How do I calculate it? I need length times width, right? What's the length? What's the width of the rectangle? Or we could call it a square because it is a perfect square. 12.2 times 12.2. What do I get?
148.
Whew. All right, and what would the area of one triangle be? We're trying a color approach this time, Izzy, but same thing. Length times width, oh, base times height, whatever you'd like to call it.
What's behind the?
Base times height divided by 2.
Is it behind the like?
Oh, like the
people.
thingamajigger.
What would base times height be for this triangle? What's the base? And that's not the base. 12.2. What's the height? 15, and then we divide it by 2. So figure out what 12.2 times 15 is divided by 2. I just meant area. Area of one square, area of one triangle.
91.5.
All right, so 91.5. Now, we need one square, which is 148.84 plus 4 copies of the triangle. And we'll get the total area of the shape. Good? Anyone hit me with that answer? 514.84?
Yep.
514.84. Now what about my units?
Feet
Feet squared. Well done. Give yourselves a hand. This is tough stuff. Give yourselves a hand. Okay, where's my clapper?
Why are you teaching us tough stuff?
All right. Before I hop off the Zoom, you do have 258 to do.
Lovely.
Now 258 has 3 more pyramids that are exactly the same as the 2 we just did. Different dimensions. Please don't talk. Number 4, 5, and 6 relate this idea of prisms and pyramids. Give a little bit of surface area problem solving opportunities here, okay? So give those a try. Tomorrow we don't have any workbook work, but I do need you to bring it so I can stamp your progress through yesterday and today's work. Notice I didn't come around to stamp because I know that you needed support with last night. So by tomorrow, yesterday's and today's should be done. Okay. There's no study guide. This is the study guide, is just our work in our workbook. This is our study guide. Let me finish up with my Zoom kids real quick, okay? I just want to make sure I answered everyone's questions today. How are we feeling at home?
I'm gonna stay
Good?
together.
Better?
I'm here.
You guys need anything else from me? Okay.
Satan and.
All right, I'll see ya. See you tomorrow. Bye.